Next up, we have a question on a complex analysis. So this is integration of complex valued functions. So the question is the value of the integral, we are given a closed line integral of the function e to the power z times sine z divided by z squared. So, by the way, if people have some question in between, if you are not able to understand, please feel free to unmute or write in the chat box. There are quite a few people who are able to understand, are answering the questions correctly. But if you are not able to understand, please don't feel shy and feel free to ask the question, and I will repeat it again for you and try to explain it a little bit better so that you can understand. So if any one of you have any query up until now, please stop me and feel free to ask the question. So this is a question on complex valued functions. So we are given a function and we are given a contour, the closed contour over which this closed line integral is to be performed, and this contour is given as a unit circle centered about a different point, z equal to 2, not z equal to 0. That is not the origin. And we need to find out the value of the integral. Now, before proceeding, I would like to write down the residue theorem for you, for all of you. For those of you who know, they have already answered, and for those of you who don't know, here is the residue theorem which we will use for solving this question. And not only for this question, you will use this for solving all kinds of complex valued functions, integrals of complex valued functions. So the residue theorem says that if we have a complex valued function f of z and we need to find out the line integral over a closed loop, then this is given by the following. Now, let me explain what each of these terms in this expression means. So this is our residue theorem, and you should remember it. It is like one of the most important topics in complex analysis that we have, and you should remember it always. So let me just explain these terms right here. F of z is a complex valued function. Why? Because z is a complex number that we have, and it can give you a complex valued results. So it's a complex valued function, and it is also single valued, meaning at some particular value of, what does single valued mean? Single valued means that for a given value of z, you only have one value for f of z. You cannot have 2 or 3 kind of values for f of z. So it's a single valued analytic function, and it is analytic inside and on a simple closed curve C, except, so it is analytical everywhere within and on the curve except at singularities. So you have a finite number of singularities. So this finite number of singularities would be the points z equal to a, z equal to b, z equal to c, and so on. And these lie inside the curve C, which have residues given by a minus 1, b minus 1, c minus 1, and so on. So in the formula that I have written, this a minus 1, b minus 1, c minus 1 are basically residues at these singular points z equal to a, z equal to b, z equal to c, and so on. And how do we find out these residues? So we have a formula for finding out the residues. So I'm writing down the formula for finding out the residues. So z equal to a is the singular point, and for this we have the residue. So for z equal to a being a pole, or a singular point being a pole of order k. So this is the expression. Let me highlight this as well. So these are important formulae. You should remember it. Now let us come back to our example and solve it. So in our example, our f of z is given as e to the power z sine z over z squared. Now, what are the poles over here? Poles would be where the function becomes singular. So that means the denominator goes to 0. So denominator goes to 0 means z square goes to 0. That will give you the poles. Now z squared would go to 0 at z equal to 0. And this is a pole of order 2. Why order 2? Because it is z squared equal to 0. Had it been z equal to 0, that would be order 1 or a simple pole. Had this denominator been z cubed, then we would have a pole of order 3. Had it been z to the power n, that would be pole of order n. So that's how you determine the order of the pole. So it's a pole of order 2. Now let us look at the curve that we are given. The curve is z, the simple closed curve is a curve which is a circle given by mod z minus 2 equal to 1. So it's a unit circle centered about z equal to 2. So opening up this modulus would give us the following, and this would be just rearranging the terms like so. So our z is confined between 1 and 3. So now notice that in this interval 0. So this means that is z equal to 0, which is our pole, does not lie within C. Does not lie within C. So therefore our integral will be 2 pi I times 0, that is 0. Why? Because our pole is outside C. So remember that in this equation, in this residue theorem, all of these poles are there, and these poles need to be inside the equation. So sorry, inside the curve. So all these singular values are inside the curve C. If the singular values are outside, then they would not contribute anything to the integral. So the contribution to the integral comes only from the singular values or the poles, which are given by the residues. But if these poles lie outside of the curve, then they do not contribute anything. So the correct option, as some people have rightly mentioned in the chat box, is indeed the option D, which is 0. Now, had this pole been inside the curve, let's say had it been z equal to 1.5. So let us say, let me just create a hypothetical situation for you. You can work this out yourself. So had the denominator been z minus 1.5 squared, okay? So what would the pole then be? Pole would be z minus 1.5 squared goes to 0. So that would mean z equal to 1.5 is the pole. And this would again be pole of order 2. And then this point lies within the curve that we have. So z equal to 1.5 lies in this region that we have. It lies within the closed, simple closed curve, that is the unit circle centered about z equal to 2. So in that case, the answer would not be 0 because this pole lies within the curve. So it will have some residue value, and that residue value will essentially contribute to your integral. So you can find out the residue for this. So order 2 means k equal to 2, and then you can find out a minus 1 from this formula right here. That would be the single derivative is involved over here. And then you can, once you find out this a minus 1, you can plug it back into this and you will get the answer as 2 pi I times the residue. So you should be careful to check whether your pole is inside or outside the curve. Sometimes what happens is that people just find out the pole and they find out the residue and then they select the answer and they feel that, well, they have solved the question. So this is not correct. The correct way is to find out the pole and then you need to check whether that pole or that singular point lies within your curve or not. Because if it does not lie within the curve, then your answer is simply 0. You do not need to put in so much effort to try and find out the residue or not. So yeah, this is some basic information about integration with complex value functions. So try to solve this question by yourself and you can post your answer in the Discord forum or the YouTube channel in the comments. I would like to see.